Hello, everyone. We are Group 8, and we are here to introduce our works in the final project, the paper replication of reimaging price trend. Our presentation consists of 6 parts. The first is the introduction of the project. The second is about the dataset. And the third part, we introduce our implementation of a traditional method, the HOG descriptor-based method. And the fourth part is the main part of the project. It is the deep learning method based on CEN models. And the fifth part, in this part, we try to interpret the CEN model by visualizing some kernels of the model. And finally, it's the conclusion of the project. For the introduction, in our project, we implemented different image classification models to predict future returns of stocks. We use images of stock level price charts as the raw predictor data. And our work followed the paper reimaging price trends to decide the data split strategy, model structure, evaluation metrics, and the robustness checking method. And other than CEN model, we also investigate a traditional method based on HOG feature and logistic regression model. And finally, we compared all the models and analyzed the results in detail. So about the dataset we used, here we introduce our samples. The input images consist of 3 components: OHLC chart, moving average lines, and volume bars of consecutive 20 days. The images of 20 days version are of size 64 by 60. And the labels takes value 1 for positive returns and 0 for non-positive returns of the subsequent 20 days. The sample period is from 1993 to 2019. So as you can see from the example here, we have pointed out all the components of this input image. So the first thing we did is to implement a traditional method based on HOG feature. So HOG is the short for histogram of oriented gradients. It's a feature descriptor used in image processing, mainly for object detection. So getting the HOG feature descriptor in our project consists of several steps. The first is dividing the image into cells of 8 by 8 pixels and then calculating the gradients for each pixel of cell. And the second step is to group the gradients into 9 bins using the directions of the gradients. So if the direction is between 2 bins, and the vote is divided proportionally to each bin. The third step is to apply L2 norm in each block, consisting of 2 by 2 cells, since we want the histogram values to be insensitive to lighting. The result feature vector has dimension of 1512, which is much smaller than the original image. So the image below shows an example. Here, the left one is the original image, and the right one is the visualization of HOG descriptors of each cell. And finally, we use logistic regression as classifier. The performance is recorded in the resulting table and was compared with other CEN models.
Thanks for my partner. Now I'm going to talk about CEN-based method. In the data preparation, values 0 to 2 are marked as the long positive returns, and not a number respectively. But our task is a 2-class classification. So we removed samples whose returns are not a number or the label marks are 2. Then, in the architecture design, we referred to the details in the paper and designed a CEN-based model with 3 convolution blocks. Each block has different numbers of 5×3 convolutional filters, leaky real rule activation function, and 2×1 max pooling layer, and with a fully connected layer and softmax layer. Then we designed a workflow which is similar in the original paper. Firstly, we divide data into 8 layers and 19 layers. For training and validation, we randomly selected 70% of 8 years data and 30% respectively. The remaining 19 years samples are used for testing. Then, for classification problem, we used cross-entropy laws and some evaluation metrics mentioned in the paper. In addition to that, we also used RC curve to evaluate our models. Finally, in the train process, we adopted some techniques like Xavier initialization, dropout, batch normalization, early stopping, and so on to avoid the overfitting issues and improve the model performance. In the end, we did ablation studies to evaluate the robustness of our model and compare the results with table 18 showed in the paper. Due to the computation limitation, we only replicated the major parameter settings in table 18, and our replication almost performed the same as table 18. Besides, we also posted the results of HOG-based method, and overall, it doesn't perform better than CEN-based method. Then, my partner will continue to introduce the visualization of our work.
Thanks for my partner. In this part, I will introduce the interpretability of the CEN model. In order to understand how CEN models decide the prediction results, a visualization method, grid-com, is used in machine learning area. Grid-com is known as gradient weight class activation mapping. We use this method to illustrate the regions of the most important for predicting a class. It can produce activation heat maps for each layer of the CEN model, which help us to observe which part of the image are important. The main idea of this method is to use backward to get the gradient corresponding to each pixel on each future map, then average each gradient map to get the weight of each future map. And finally, the final class activation graph can be obtained through the activation function. In this project, we mainly interpret our CEN baseline model. We draw both up and down images in 2019, respectively. The following first row is an up example, and the second row is a down example. The first column shows the original images, and the next column shows the grid-com heat map at each of the CEN 3 lines, respectively. For both up and down example, we can see that CEN is most intensively activated when the high-low range is wide. In the first and second layers, we see that CEN model pays special attention to open and close prices. And in the third layer, image shows that the higher value days are much more important. And in the second and third layers, we also find that up sample is activated in the upper regions of the image, and down sample is activated in the bottom of the image. In conclusion, in this project, we implement two methods to solve price trace problem, which are CEN model and HOG-LR model. The results show that CEN model performs better than HOG-based model. We also perform sensitivity analysis of the CEN prediction model. We use cross-entropy loss, accuracy, Spearman correlation, and Pearson correlation, and AOC as our evaluation metrics. The results we got is similar with the original paper shows in table 18. Finally, we use a visualization method, grid-com, to interpret our CEN model. The results shows that CEN model has ability to extract nonlinear associations between prices, high-low range, and volume to obtain successful return prediction. Okay, That's all about our final project's presentation. Thanks for listening.